Hello and welcome to helpyourmath.com. In this video, we are going to look at applications of the natural base e. Keep in mind that e, while it looks like a variable, it's not. It's representing an irrational number. So it's the irrational base e. Make sure you have a calculator handy because we're going to need it, and make sure that calculator has an e button. It usually says e or e to the x or something along those lines. Okay, in our first example, Benji has an account with $4,000 that compounds continuously. If the interest earned is 2.3%, how much money will be in the account after 10 years? And the formula that we want to use is A equals P times e to the RT. Remembering e is not a variable, it's the base, it's a constant. A is the amount in the account, P is the amount invested, R is the interest rate, and T is the time in years. So let's label everything we know. We know that Benji started out with $4,000, so that's the amount invested. The interest rate is 2.3%. Since we can't actually use it in percent form, we're going to convert it to its equivalent decimal by dividing by 100. Dividing by 100 is going to move the decimal point 2 places to the left, giving us 0.023. And we know that t is 10 years, so t equals 10. What I want to do before I actually plug in is it's really important to me that we do this calculation first because we don't want to have an order of operations mistake. So just before we actually plug in, just calculate r times t. That's going to be 0.023 times 10, which will give us 0.23. Now let's plug in. So we have A is equal to 4,000 times e to the 0.23. And when we do this calculation, we're going to make sure we round to the nearest penny because this is money after all. And after 10 years, Benji's going to have $5,034.40 in this account. So we can see the original $4,000 that he invested, and the interest earned was $1,034.40. Not bad, huh? Let's look at one more example. The number of bacteria in a culture is given by the equation n of t equals 20 times e to the 0.4t, where t is time in hours. How many bacteria are present initially? How many bacteria will be present in 12 hours? When we're given a formula, we are actually given the initial amount. The initial amount is found right here. This is always the initial amount. So it's the thing that's being multiplied to the base is the initial amount. So we know that initially there are 20 bacteria. Now, if that kind of makes you worry, like, ooh, I don't know about that, you can always do this mathematically. Mathematically, this means that t is equal to 0, right? Initially is at the onset, at the start. If you plug in 0, then our exponent of e will be 0.4 times 0, which is 0. And then we would have e to the 0, which is 1. And 20 times 1 is equal to 20. So just two ways that we could get there. Okay, so this was like the first question, so I'm going to call that A. Now let's look at the second question, B. How many bacteria will be present in 12 hours? So in this case, t is equal to 12 hours. What we want to make sure is that the units here match the units here. We do have hours and hours, so we do get to use t is equal to 12. If one of them was given as days, we would want to be very careful about the fact that 12 hours is half of a day. But they match up, so we're going to use t is equal to 12. And before I actually plug in, I again want to just calculate that exponent. So the exponent here will be 0.4 times 12. And if we multiply this out, we're going to end up with 4.8. So now I'm ready to plug in. This is going to be n of, and I'm replacing t with 12, is equal to 20 times e to the 4.8. And it looks like after 12 hours, this bacteria has skyrocketed up to 2,430 bacteria. So there's 2,430 bacteria at 12 hours later. And that's it. There's our natural base. These have been examples of applications of the natural base. Thank you for stopping by.